Here's another sample of using Hess's law. Now this one represents a rather difficult breed of problem. Okay, so calculate the enthalpy of formation of propylene, C3H6, using enthalpies of formation and enthalpies of combustion. Solve by combining the known thermochemical equations. So major hints given, all right, but let's go through this step by step. All right, the first thing that I want to know is the enthalpy of formation of propylene. Well, if I look on the table, okay, you'll notice that C3H6 is not one of the compounds that I give you. Okay, so problematic. So we're going to have to solve this another way. What I'm looking for, I can write this out, is the enthalpy of formation. Okay, so I can write the equation for this. I know that this needs to be a 1, and so this is carbon plus hydrogen gas, and carbon only 3 of those, and hydrogen gas only 3 of those. 3 times 2 is 6. Okay, so this is the equation that I'm trying to find. All right, now it says here using enthalpies of formation and enthalpies of combustion. All right, well, the one that you're probably going to want to start with is the enthalpy of combustion, okay, because you don't have the enthalpy of formation of this. You do, however, have the enthalpy of combustion of C3H6. There it is right there, propene, C3H6, negative 2058.0. Okay, so delta HC is negative 2058.0 kilojoules per mole. All right, so now we got to write this enthalpy of combustion equation. So this is C3H6. Now remember, I have to burn 1 mole of this, plus oxygen yields CO2, gas, plus H2O, liquid. And then I'm going to have to balance. I'm going to need 3 of these. I'm going to need 3 of these. And so this is 3 times 2 is 6, plus 3 more is 9, so I need 9 halves oxygen. Okay? All right, so let's look at where we are. We now have the C3H6. We know that we're going to have to flip this equation, okay, to get this on products. But when I do that, I'll have CO2 on reactant side and I'll have H2O on reactant side. And that's done. I mean, I need carbon and I need hydrogen. I don't need CO2 or H2O. So my question to you is there a way, is there an equation that we can come up with that has CO2 in it, that we can find information for? All right, so I want you to pause, I want you to think about it, and if you have it, just do it, okay? The best way to get rid of CO2 is going to be to do an enthalpy of formation of CO2, which is data that we have. Okay, here's carbon dioxide, CO2, negative 393.5 kilojoules per mole. All right, so now I need to finish writing this equation. So this is carbon solid plus oxygen gas, and everything's 1 to 1 to 1. That's nice. All right, and now you should realize that I can do the same thing with water. Okay, I can make up this equation with water, and it has to be liquid water so that it can get rid of the liquid water. All right, so the enthalpy of formation of liquid water is liquid water negative 285 0.8 kilojoules per mole. All right, and this comes from hydrogen plus 1/2 oxygen. This is gas, this is a gas. Okay, so let's take stock of where we are now. I'm going to be able to cancel out the CO2s and the H2Os. All right. And I now have a way of getting carbon from here and hydrogen from here. And then I'm just going to have to hope that the oxygens work out. So let's not worry about the oxygens right now. All right, I know that I'm going to need 3 carbons. So I'm going to multiply this whole thing by 3. And here, I'll even put that in there so I remember to do it. And I need to multiply this by 3 to get my 3 hydrogens. Okay. And so now when I rewrite these, I'm going to give myself a little bit more room. Okay, so I flipped the first one. And I'm actually going to move this over a little bit. Okay, I flipped the first one, so I've got 3 CO2 plus 3 H2O liquid. And that's going to make C3H6 liquid plus 9/2 O2. And delta H, because I flipped the sign, is 2058.0 kilojoules per mole. All right, and then the second one is 3 carbon plus 3 oxygens yields 3 CO2s. Delta H for this is going to be 3 times negative 393.5 kilojoules per mole. And then this last one is going to be 3 hydrogens plus 3 times 1/2 is 3/2 oxygen gas makes 3 waters, CO2 gas. Delta H for this is going to be 3 times negative 285.8 kilojoules per mole. You're right. So I've got rid of all these. All right. So this is the good stuff down here. All right. So now I can collect like terms, look for stuff to cancel out, and in general just solve the problem. All right. So stuff that cancels out. Here's a water that cancels out with this water. Okay. Here's a CO2, 3 CO2s cancel out with these 3 CO2s. All right, and then the last one is going to be the oxygens. Okay, so I have 2 oxygens on this side, and I have an oxygen over here. So 3 oxygens plus 3/2 oxygens, so you need to get a common denominator, so that's 6/2 plus 3/2 is 9/2, which is what I have over here, so all of this goes away. I forgot to cancel this out too. Okay, so now all that I'm left with is 3 carbons plus 3 hydrogens yields C3H6 liquid, delta H. Now this is a formation reaction. And then I just do the sum of all this stuff, and I get 20.0 kilojoules per mole. And I think that's 20.0 kilojoules per mole. Okay, so there is, this is what I'm looking for. Okay, and here's my answer. So this is a lot of work to get to a problem like this, to an answer like this. And so this is going to be like kind of the hardest type of problem that you have from this bit on the test.